Okay, we're in 28, and we're talking about the Sage code. What I want to claim to you over here is that a lot of the stuff that we've covered here is stuff that's been covered in Math 120, right? We're kind of just going through a review. Now, certainly there is calculus to learn as well, but I always say prerequisites are needed. So I'm just going to just go through the Sage code and reset. Now I'm defining a variable, and it's a multi-letter variable. It's just, I'm going to say theta now is a variable. And what's that variable? It's theta. And I did that. And, I'm going to say that R is a function of theta now. I'll read this to you. Your goal is also to read, though. What does it say? R theta is equal to 4 times 1 minus 2 sine of theta. Well, that's pretty simple. And then this one over here, I want to do the polar plot. Again, this is, certainly we're going to polar plot, see what happens. And what are we plotting? We're plotting the function at R theta for theta between 0 and 7. And what's 7? It's bigger than 2 pi, certainly. What does it do? It launches it. I get this picture over here, right? A lot of students find it challenging to graph polar equations, and they do. They find it challenging, all right? They are challenging. They're much more challenging than, the basic stuff you learn, like in Math 100 and then 119. Then when you get to 120, you had trigonometry, and things got, for a lot of students, substantially more difficult, all right? But anyway, that's a nice looking plot. And, certainly, if I do this one over here, and again, all I'm doing is copy pasting. What does it say? R is a function of theta. That's the radius, by the way, is equal to 8 minus secant of theta. All right. And again, this would be a challenge for a lot of students to plot. What I want to do is I want to plot it out. Again, I'm just doing a copy paste. What's that? Now there's a new R theta. And what's that R theta? It's the 8 minus secant of theta. But again, I'm going between 0 and 7. And 7 is definitely bigger than 2 pi. All right. Whoa, that doesn't look right. I don't see anything there. I see something that looks crazy. I don't know what that is. So I want to talk about this in a little more detail. It's going to happen to you. And what I'm going to do over here is I'm going to do a polar plot, and we'll talk about that. All right. Now, what happens over here? They're saying, keep the X between -5 and 5 and the Y between -4 and 5. Let me do that. And I get a better picture. All right. Still not the picture I want, by the way. It's going to be a tough picture to do by hand. So I'm going to revise it. And you're going to be playing around software a lot too. All right. So what am I doing there? Well, I'm keeping the X's the same, but now I'm taking the Y's and making it much wider. Right. I'm getting a better looking picture. Okay. I want to close this out though. And I always say that you should become familiar with software that you like to use. Now, what kind of software I use? I like to use Sage. I like to use Grapher. I like to use Wolfram Alpha. I can't use Mathematica anymore because I don't have the license for it. But in the past, I like to use Mathematica. You may say to yourself, well, I don't like any of those products. I want to do something different. And you know what? You really want to be different. You want to start to use things that you find helpful. I found it quite beneficial to use software that I find helpful because one is I enjoy using it and I can use it. All right. Now, if you say you have to use this or that, I don't like that attitude, but a lot of people, like when you go to NJT, they're going to make you use MATLAB. At least I think they will. They might have changed your mind on that, by the way. I'm not saying it's a bad product. I'm just saying I would rather have tools, not one tool, but tools, a lot of tools. And certainly I like Sage, but I like Grapher better. And what I want to do is I want to graph this guy out using Grapher. All right. So what do I want to graph out? I think it's easy to use too. I want to graph R equals, right? Remember, this is tough. 8 minus secant. And I'm going to type in the theta now. And I'm going to actually use my palette to do it. And I don't know, maybe you can't do it. Maybe it's going to blow up on me. Who knows? Well, you know what? I'm seeing something, but it doesn't look right to me. Right. So what I'm going to do is, and I like to customize my graphs. I'm just going to do the format and I'm going to do accent grid. I want to get rid of the grid because it really disturbs me. And the frame. I'm always doing that. And what I'm going to do is I'm going to start to zoom out because I don't think this is the right picture. And I'm seeing it now. I'm seeing a much better picture, a much better picture. Now, when I say a much better picture, even better than Sage, I want to point something out though. Sage can do this too. I mean, Sage can make a much better picture too. I've just got this over here. So I like Grapher. But again, you may look at Grapher and say, well, yeah, I got something better. If you do find something better, we are going to encourage you. Share your ideas with other people. Start to promote that, all right? Just like at school, I try to promote among the faculty. A lot of faculty are very resistant to using technology, but I do try to promote technology to other faculty members. Now, if you look back over this material, you're going to notice I come up with some spiffy graphs over here. You may want to try to reproduce these guys over here. And again, you may say to yourself, I'm going to use this tool or that tool. Use a tool, all right? Now, your tool might be paper and pencil, and if you're good at it, people will be impressed by it. Most people are not good at it, though, all right? So there's a lot of stuff over here. You know what? Let me graph this guy out over here. I'm going to go back to my grapher software, and I'm going to see if I can do that. I got to see if I can learn. And part of learning is doing and playing around, including you're going to, mess it up, right? So let me just see. I get my grapher back, and I'm going to graph this guy out now. What is it going to be? Well, I'm going to type it in. It's r squared, and r squared equals 81 star. And who knows what's going to happen? Cosine, and that's twice theta, right? So 2 theta. I'm going to use my palette again to get the theta. And let's see what happens. Gee, I see it. And what I'm going to do is I'm going to zoom into that. All right. I'm not zoom out, zoom in. All right. You can zoom in. By the way, if you want, you can refine these graphs a lot. Let me go up in an inspector, and I can make the resolution better and better. All right. Now, someone says, I don't even notice a difference there. There is a slight difference between the two curves. Maybe hard to appreciate. If you zoom in, though, you'll see the difference. All right. If you zoom out, you're probably not going to see the difference. All right. But did I get the same graph that this guy got? Of course I did. You notice this one's colored and the numbers are taken off it. All right. So you may want to go back over the notes and draw pictures. All right. You may want to draw these pictures over here. So I'm actually going to draw this picture here. And there's 2 pictures there, right? So let me see if I can do that. And again, I'm going to say r equals 2 theta. I'm going to use my palette to do that. I think you remember me doing that before. I see that. And I'm going to graph out that other thing. And what is it? I'll have to type it in. And I want to see if I can reproduce this. Part of reproducing what you see is a pretty important first step in learning, right? It's an important first step in learning. I'm going to put another graph in, and I'm going to mix, Cartesian with polar, and I can do that because the polar graphs are still being graphed on a Cartesian coordinate system, but this is minus 2x divided by 3 pi. I'm just typing in minus 3 pi. Okay, I did that. I'm not seeing it though, right? So what I'm going to do, I'm going to zoom out. And now I'm seeing it. And the question is, am I seeing the same thing? I am. I'm seeing the same thing. Now, granted, someone says, well, you know what? You made a prettier picture here by putting the point down and stuff. Yeah, you can do that. And you may want to learn by trying the software that you enjoy to use, right? It could be a handout calculator. You might have something in your cell phone. Start to learn to use software. Software is an important component of your educations, all right? And learning software, not in some kind of hackish way, but learning it, appreciating what you're capable of doing, and having a variety of tools at your availability. All right, so I'm going to call it quits on that. And again, I encourage you, give it a try. Thank you.